Continuing on the January 2018 exam. Number 7, cone, right circular cone. Okay, so what we have, if you take the time to draw it out, is the entire diameter 6.6 centimeters. We don't know the height, so it looks like that's what we're trying to find. So make sure we know that the radius then is 3.3. The volume formula for a cone is on the reference sheet. Now, what's strange about this one is this is working backwards. Hopefully we do a little better with this. Typically it's not great. So we want to work backwards. When they give us the volume, we simply plug it in for V. Now this is up to you. You are welcome to use your calculator to get the decimal of that. I'm not gonna. That's just my personal preference. So what I'm going to do first is I'm going to divide both sides by pi, get rid of the pi. It just happens to work out that they're gone now. That's why I'm going to do it that way. A third times 3.3 squared, that's 3.63. So now I'm going to divide by 3.63. So I get the height. Let me just do that quick. 3.63, 15 it looks like. So we get a height of 15. Yeah, they did look at this. This is a common mistake because some folks forget the 1/3. So please be careful and don't fall for that one. All right. Number 8's interesting. Okay, so when we use the algebraic notation or the rule, or writing the rule for a transformation, sometimes you go say x, y to, negative x, y. Okay, so what that indicates is that the x value switched signs. Okay, that would be an indicator that it's a reflect over the y-axis. Okay, now there's a whole different method to figuring out what actually happens, but I don't want to get into that right now. I just want to show you that this algebraic notation or the rule tells us what's going to happen to the coordinates, and then we can figure out what the transformation is. Okay, so you're going to see this type of thing once in a while. Now, what they did that was a little strange here was they went and multiplied the coordinates. Now, if we multiply the coordinates, that's going to be changing the size or the distance away from the origin or something like that for the figure. Now, when we multiply by different numbers, it actually results in a stretch. Okay, for instance, let's say we did xy maps to 3x, 3y. That would be a dilation because we multiplied both coordinates by the same amount. But when we multiply by different amounts, we end up with a stretch. Okay, now look at this one. We multiplied by 2 for the x, and we really multiplied by 1 for the y. So that is also a stretch. This is a stretch because, again, multiplied by different numbers. Here, we really multiplied them both by 1 and added, let's say we added 2 or added 3. When we add a different number, that's okay. That becomes a translation. Okay, so these stretches messed up distance and angle. Okay, a translation would have kept both. Dilation would have kept angle but messed up distance. So translation is going to preserve distance and angle measure. So select that one. A little tricky. When we multiply the coordinates, that's an indicator that something's going wrong. All right. Let's see. So this one is trying to make sure that you know and have to use the exterior angles theorem. All right, that theorem is that the sum of the measures of the two remote interior angles in a triangle is equal to the measure of the exterior angle. So this is the exterior angle, and these are the two remote interior angles. If we add these, it should equal this one by itself. So that's what we're supposed to have taught you. Now there's ways around this, of course, which I'll show you some strategies in a minute here. But let's do it the right way first. Let's do this the way that it was intended. So, combine like terms, 7x. Be careful here. I notice a lot of mistakes when my students do this problem. We're just combining like terms, so we're not adding or subtracting to both sides yet. Make sure you don't skip steps or attempt to skip steps and miss this. Negative 40 and positive 20 is negative 20. Okay? So we combine like terms. Now we can use our solving methods. In this case, I would probably add 3x to both sides. Okay, so 10x minus 20 equals 180. Add 20. So now it's just mechanics of solving equations, but I'll finish it off for you. I'm sure we're not done after that. We'll probably have to plug back in for some reason. All right, so 10x equals 200. Divide by 10. X is 20. Yeah, we're going to need to plug back in because it wants the measure of angle BAC. Now that angle is right here. All right, so if we plug back in or evaluate using 20, let me just redraw this. What you're going to find is throwing 20 in here. 20 plus 20 is 40. So that angle right there is 40. 6 times 20 minus 40, 120, 80. Okay, it's going to be 80. If we plug this in, it should be 120. And I would say 180 minus 120 is 60. So the measure of angle BAC is 60 degrees. All right, number 10. This one typically ends up stumping more students than I expected. Continuously rotating something about the y-axis. What we're used to probably is two-dimensional rotations. Say we're going to rotate about a point, all right, that's just going to move the figure in that same 2D plane. But when we rotate around the y-axis, it's essentially making a sphere, bottom half of a sphere. So let's imagine that that's happening. So that's the bottom half. If you look, if you can see this, it's a bottom half of a sphere. All right, the rest of the sphere would look like that, but we don't have the top of the sphere. So it should be a half sphere. Pretty tricky. Okay, it's the image. Okay, so we have triangle ABCD. I like drawing it to, maybe I'll misdraw the first thing, but I'm going to try drawing it to see if it can help me explain and understand this problem. Now, it's a dilation centered at A by a scale factor of 2/3. You could make up some numbers if you wanted, but basically, if I split this into 3 equal parts, and I go 2/3, A is going to stay still, or A prime I should say, is going to stay there. B prime is going to end up there. This is C prime, and this is D prime. Now the rectangle has a perimeter that is 2/3 of the perimeter of rectangle ABC. That's perfect. So the perimeters will have the same ratio of sides. Perimeter ratio is equal to side ratio. That's important. Now, area ratio is, now this is where it gets tricky. Remember, for area, it's two-dimensional. So you're going to have, for one side, you're going to have a ratio of 2/3. For the other side, you're going to have a ratio of 2/3, and you're multiplying those. So it's the square of the side ratio. So in this case, it'd be 2/3 squared. 2/3 times 2/3 is 4/9, would be the area ratio. So that's kind of the trick in this. So it's difficult to choose between perimeter and area here, but the area is not 2/3 of the area. That's not going to work. 3/2, definitely wrong. This one says the image has a perimeter that's 3/2, which would indicate smaller. This was an enlargement, so, I'm sorry, I got it backwards, my fault. That would indicate an enlargement 3/2. What we have is a 2/3, which is a reduction. Anything under 1, k less than 1 is going to be a reduction. And 2/3 is less than 1, so we have a reduction here. So we want the reduction as 2/3. All right, number 12. I've encountered this before, and what I want to say about that is I know that there are some ways that are being taught out there with the graphing calculator. The TI Inspire can solve this. But what I'm trying to do is make sure that we, make sure we have some good math and teach you the way that's intended. The way that's intended is to complete the square, and that's going to get us into center radius format. Now, what it's going to take is, I'll rewrite it. What it's going to take first is some rearranging. All right, so I would put the kind of the x terms together first and try to understand what's going to happen here. We're going to try to turn it into a square like this. What we've got to do is understand this is equivalent to x squared minus 6x plus 9. Okay, so that's something that we talked about at length in class. X minus 3 squared is the same as x minus 3 times x minus 3. This is the knowledge you need to have to even do this. Now when we double distribute, we get this. Combine these terms, 6x. Okay, so that's what it looks like. This is the y. Now, we have to know that. Pretty cold to be able to complete the square. So, here's what I'm going to do with rearranging. What's going to happen is we're going to be missing a number. In this space is the number that's going to complete the square for us. So we're going to hold off and we're going to come back and fill that in a minute. Now we're going to go with plus y squared plus 2y, and again, we're missing a number there that will be used to complete the square. Now, whatever number I add here, I got to add there. Because it's an equation, we want to stay balanced. Likewise there. Okay, so this is the setup. Now I'm going to skip ahead a step. What's this? What are these three going to turn into as far as a perfect square? Cut that in half. You get x minus 3 quantity squared. Well, what number is missing that would allow us to complete that square? Because these three numbers are all going to go into there. And it's negative 3 squared, which is positive 9. Okay? Now, don't forget your plus sign. These three are all going to combine into something squared. It's y plus 1 squared. 1 squared is 1. So that's the number needed to complete the square. Now, whatever I added to the left side, I have to add to the right side. I added a 9, so I got to keep it fair. I added a 1, got to keep it fair. 6 plus 9 plus 1 is 16. And now our center can be found off of the equation. It's always the same number but opposite sign. Okay? And radius is going to be the square root of whatever's on the right side of the equation. So in this case, it's 4. So we want to center 3, -1, radius of 4, choice 2. That'll be it for this video. Next batch will be done on another video.